Okay, hello everyone. Good day. And this is teacher Justina and telling you to subscribe if you are not yet done and to not forget to hit the notification bell for more video updates. Our video for today is all about the third law of exponents, which is power of a power rule. Okay, and then it says that when a base is raised to a power and the whole expression is again raised to another power. So as you have seen, it is expressed in this notation x to the power of m to the power of n. And the simplified form is simply, we just copy the base, which is x to the power of m times n. Meaning, in this law, we need to multiply the exponents. Multiplying the inner exponents to the outer exponent. Okay, multiplying the inner exponent with the outer exponent. Okay, so let us have the several examples. Okay, we have c to the 6 quantity to the power of 7, and of course, as the law says that we need to multiply the inner, which is 6, times the outer, which is 7. So it is now giving you a product of c to the power of 42. While number 2, h to the 6 to the power of 2. And thus, the final simplified expression is now h to the 12 because 6 times 2. And then number 3, you have in there that the x plus y as our base. Then raised to the power of 3 as our inner exponent, multiplied to the outer, which is 3. Then it will give you this process. And then final expression will be quantity x plus y to the power of 15. Okay, again, remember, do not forget that x plus y to the 15 is not equal to x plus y to the power of 15. So, you have to be careful on the parentheses and the without parentheses meaning. And then number 4, you have the c to the 5n. As what I have said, that exponent is not necessarily a constant number. It could be a variable. So let's now have the c to the 5n to the power of 7. So same concept, we just simply multiply. 5 times 7 is 35. And then we have to multiply the n to 35. So therefore, c to the power of 35n. While number 5, we have 2ab to the power of 4 to the power of 5. So the inner and the outer will be now multiplied, and thus it is 2ab quantity to the power of 20. Let's proceed to this next example. So let us have consider this expression that if we will be multiplying with negative exponents. So in this case, we'll be having the inner exponent, which is negative, times the outer exponent, which is negative. So the same thing that we did in the previous example, we simply multiply the negative m times the negative n. And thus, we have already the idea that if we multiply both negative numbers, we will come up with a positive product. So therefore, same process, we just simply multiply the inner and the outer. So we have number 1. So 8 to the negative 2 to the negative 7. So of course, multiplying both negative, we have 8 to the 14. And 8 to the negative 2m times negative 3 will give you negative 2m times negative 3 is now giving you 8 to the 6m. And then number 3, you have in there that the 5y, quantity of 5y has a negative 6, and there is a negative outer exponent. So we have to multiply them still, and will give you quantity of 5y to the power of positive 6p. So number 4, the t is being raised to negative c to the power of a negative w. So therefore, the final expression will be t to the power of cw. So meaning in this expressions, we have to come up with positive exponents as our final answer. Sige, let us have another uh, case. So what will happen if its exponent in the inner part is negative and the outer is positive? Or the inner exponent will be positive and the exponent will be outside is negative. So the same process that we did, we simply multiply the negative m and the n in this notation and as well as in this notation also. So, but you have to remember that multiplying different signs, we always come up with a negative product. And remember that we are going to recall in the second law of exponents, the quotient of powers, if a base raised to a negative exponent, it will always be simplified in this manner. Again, it will be expressed in a fractional form provided that you will have a numerator of 1 and the base, which is a, will now rewritten and the negative n will be now positive. So remember, it is already in a fractional form, and this will only happen if our exponent is negative. So let us try number 1. So that's it. C to the negative 8 times 5 will give you z to the negative 40. And since this is negative, it will be expressed in this way. So 1 as our numerator and then z to the power of 40. And once you were able to express it in this way, remember that our exponent is no longer negative but it's already positive. So number 2, it will be giving you 5 to the negative 8 and thus 1 over 5 to the power of positive 8. While number 3, you have there 8 to the negative 5 times positive 2. Then it is now 8 to the negative 10. And 8 to the negative 10 will be simplified into 1 over 8 to the positive 10. And last, number 4, we have v to the 6 to the power of negative 9 will be, what is 6 times negative 9? I'm sorry, it is negative 54. Okay, so if it is v to the negative 54, then the final simplified expression will be 1 over v to the power of 54. Okay, so we are done with the first three laws of exponents. Let's proceed to the fourth law of exponents, the so-called power of a product. So the power of a product says that we are going to, why it is said to be power of a product? Because we can consider that the bases that we have inside the grouping symbol is expressed as a product. So it is no longer one base inside the grouping symbol, but it is more than one already. So as what we did, we just simply multiplied the inner exponent to the outer exponent, or in other words, we simply distribute the outer to the inner exponents. So we will now have x as our first base will be raised to x to the m times n, while our second base is y raised to the power of m times n. So we simply multiply the exponents. So let us now consider these following examples. Number 1, so since as what we have, that we have two bases inside, and with the x has a 1, there is a 1 in there, so 1 times 3, we have 3. And the y has an exponent of 2, you simply multiply 2 times 3, it's a 6. And that is your final answer. And then let's proceed to number 2. You have there the 2 as a base, the x, the y, and the z. So therefore, we have considered that the 2 has a power of 1. There is a 1 in there. So 1 times 7 will be 7. And the x also has a 1. So 1 times 7 will be also 7. The y has a 2, thus this will be y to the power of 14. And then the z has a 3, thus 3 times 7 will be 21. And this is our answer in number 2. Then let's proceed to number 3. Number 3 has x to the power of 2. Thus, I know that this is from the third power, no? X to the power of 2 to the power of negative 3, this will become negative 6. And since a negative exponent is unsimplified, not unless it will be expressed into uh, 1 over x copy, the negative 6 becomes positive 6. And then let's proceed to number 4. So number 4, we have x to the power of the 2 times negative 3 will be negative 6, and the y has a 1 understood. So this will be y to the power of 1 times negative 3 is negative 3. But that is not yet done, no? That is still unsimplified. The x to the negative 6 again can be expressed, or not can be expressed, but should be expressed on its positive equivalent. So this time the x will be copied and the negative 6 becomes positive 6. And the y to the negative 3 is 1 over y to positive 3. And now apply the law of multiplication of fraction. This will be 1 times 1 is 1. And the x to the 6 will be copied, and then the y to the 3. So therefore, this is the final answer. While number 5 is 2 to the 2r to the power of 4 to the power of 5. And then this will be simplified as 2 to the power of, understood that there is a 1 in here. So this is 2 to the 5, and this is r to the 20. So you just leave your answer in this way. And then number 6, we have negative 2, then p to the 7, and then uh, raised to the power of 7. And for this, remember that again the 2 has an imaginary 1. So copy negative 2, then the 1 times 7 will be 7, and the 7 times 7 will be 49. Remember, our exponents are both positive, so you need not to simplify it in other form. Guys, I hope uh, you've learned the different laws of exponents from the first law down to the fourth law. I hope you will still follow me in my channel for more videos to come. Thank you, everyone.